Good day. Today we're going to have the probability of an event. This analyzes the course outcome, compute the probability distribution of a random variable for both discrete and continuous data. The intended learning outcomes are defining probability, relating counting techniques to real-life situations, computing for the probability of an event, identifying ways of solving for the probability of an event, differentiating discrete and continuous random variables, solving the probability of real-life situations, use the rules of probability in solving probabilities, and relating probabilities and reliability. What is probability? Probability is the branch of mathematics concerning numerical description of how likely an event is to occur or how likely it is that a proposition is true. A random experiment is an experiment that can result in different outcomes, even though it is repeated in the same manner every time. Examples: measuring the energy lost in a simple machine, measuring the strength of steel. First, let's discuss what a sample space is. Sample space is the set of all the possible outcomes of a random experiment, which is usually denoted by a capital letter S. Example: consider the experiment on tossing a die. A die is the singular for dice. So it is a box, or it is a cube with numbers 1, 2, 3, 4, 5, and 6. So if you're going to have the sample space for the number appearing on the top face, we will be having the sample space to be S is equal to 1, 2, 3, 4, 5, and 6. If we will be discussing another event, um, for example, the sample space for the number appearing on the top face, whether it is even or odd. So for this one, we are going to take note that 1, 3, and 5 are the odd numbers, and 2, 4, and 6 are the even numbers. So our sample space S2 is equal to either odd or even. Now, there are two general classification of sample spaces. It can be a discrete sample space. This is a sample space when it is consisting of a finite or countable infinite set of outcomes. So taking note that it should either be finite or countable infinite number of outcomes. So the possible outcomes would be 1, 2, 3, 4, and so on. Usually this arises on counting. We also have, um, for examples, the sample space for the number appearing on the top face of the die. So that would be S is equal to 1, 2, 3, 4, 5, and 6. So this is a discrete sample space. Let's have another experiment. This is a sample space for a thrown die until a 5 occurs. So our possible outcome would be a 5 or a non-5. If we're going to toss a die, it can be a non-5 or a 5. So if a 5 occurs, the experiment is halted or is terminated. While if it is not terminated, so we toss the die again, so we have N or F. So if the outcome is a 5, we end the experiment. Otherwise, we toss it again. So it is N or F. So the list of possible outcomes are a 5, a non-5 followed by a 5, a non-5s followed by 5, and so on and so forth. This is an infinite countable set of outcomes. While for continuous sample space, this is a sample space consisting of intervals for finite or infinite real numbers. Example would be the life in years of a certain component. Let us first consider the number line. So if this is 1, 2, 3, 4, if we are only taking values 1, 2, 3, and 4, it would be discrete. But if we're going to accept that there are values in between 1 and 2, it would be continuous. So it would be discrete if in between 1 and 2 there are no other values, but if there are infinite values in between the interval, it would be continuous. An event is a simple experiment that has two or more possible outcomes. An event is the subset of the sample space of a random experiment. Consider the events E1 and E2. So let's have this one as E1, which is A, and E2 as B. If we are going to consider the complex operation between these two sets, E1 and E2, we can have the union, the intersection, and the complement. The union of two sets designated by U or union operation is the set that contains A or B, or event 1 or event 2. It satisfies event 1, event 2, this is event 1, this is event 2, and the event of intersection E1 intersection E2. While the intersection of two events, which is designated by this symbol, denoted by this one, is the set of events such that it would be E1 and at the same time E2. So this is E1 intersection E2. So it would be E1 and E2 at the same time. While the complement of the event is denoted by prime, is the set of event not on the given set. So our keyword is not. So not in E is the complement of E. For mutually exclusive events, that means there's no intersection. Graphically, using Venn diagram, we can visualize that as this one. Observe that there's no common region between A and B. So since there's no intersection, we can say that they are mutually exclusive. As a simple example, let's have a coin problem. If you're going to toss a coin, the possible outcomes are head and tail. So if the outcome is a head, you cannot get a tail. But if the outcome is a tail, you did not get a head. It's not possible that you get the head and the tail at the same time.